Okay, hi guys. Sorry, this is going to be probably an awkward video. I have no one to film it for me but me. So I had put up the PowerPoint, which you should have viewed before this, because it would show you like the activities, and I would have done it when I was doing the PowerPoint, but I can't do that. So I'm just going to kind of show you what would have happened. So I had talked about showing a demonstration and with a bouncy ball. So the demonstration would have just been like I would have dropped the bouncy ball and you would have seen the motion. It bounces back up, gravity pulls it down, kind of thing. And the demonstration that I would have done with the softball, as I talked about, would have just been me flicking it, and then it's gonna fall, and eventually something's gonna stop it. So it hit the curtain and it stopped. And then I had a first activity that I would have done, and that was with a track I had made, and I'll show you that track right now. Let me get it set up. So the track looks something like this. So I had made this, and it's just a piece of wood, and it has 3 different lanes. And one lane had sandpaper, one was just the plain wood, and one I put aluminum foil on. So I'm just gonna lay it down on a flat surface to demonstrate the first activity, which I would have taken this toy car, and I'm gonna show you, I would just flick it and see how far it would travel. And that's to demonstrate how a force makes motion and see how far that would travel. So see, it moved further on the aluminum foil so far than on the wood. Then I would do the sandpaper and I would just flick it. And see how far that would travel. And yeah, something that you could argue would be that, how do you know I'm giving the same force every time with my flick? And that's a good point. And that would be something to discuss with the students. So maybe this had a lot more force than the last flick. So it went further. Does that mean the aluminum foil made it travel further? You would have to kind of do it with the same force, right? So even with the sandpaper, see, that time it stopped because it got caught on this. And with the wood, didn't travel that far this time. And that would be for activity 1, and then we would have gone over the essential questions and discussed. For the activity that you guys would have done by yourself, I had made 2 separate tracks, and I also had these to stand them up on. So obviously one set's longer than the other by, I believe, like one's 2 inches and one's 3. And you each would have gone into groups, and then we would have been testing the track, and we would compare at the end with height as well. That would have been another factor. For this example, I'll just use the smaller ones, and I'll set up the track real quick. Which is gonna look something like this. Just stick these in here like that. And I just lean it up against the wall, like so. Okay. And I did have a piece of wood that would have stopped it at the end, but I'm just gonna use this chair in this example. So you guys would have gotten a piece of paper in your groups, and it would look something like this. So team names at the top, race car, bouncy ball, 2 different tests. You would do 3 trials in each. So 3 trials for the sandpaper, 3 trials for the wood, 3 trials for the aluminum. And I would have had you use your phones to record the time. I'll demonstrate right now. So someone would just let the toy car go, like so. And then someone would have recorded the time when it stopped. And then the same would have happened. You would have ran that for each, you would have done that 3 times for the sandpaper. Then you would have done it 3 times for the wood, and you would have done it 3 times for the aluminum. And then I gave you some instructions, and it says the formula is distance over time. You would get the average time for each track. So after you ran your 3 trials, you would average the times. And then I let you know that the distance of the track is 48 inches. Each track was the same. And then you would insert it into the formula to measure the motion of the object. And then you would do it for the bouncy ball, which I have right here. And I would let the bouncy ball go, like so. And we would see the difference between the bouncy ball and the race car. And we would also compare between the heights. And that would just kind of give everybody an example of motion and how forces such as sandpaper or wood or aluminum or forces such as a flick have effects on motion. And you can describe it. And you can describe it by doing distance over time, how far the car traveled and how long it took it to travel and what were the forces acting upon it. Again, sorry this video is probably really awkward, but I had no one to film it and I didn't really know how to film it, so this is what we're doing.